Welcome back, everyone. I hope everyone enjoyed lunch, and I want to especially welcome our online audience, and we're looking forward to a very nice second set of sessions here at Haystack. I want to welcome also Lucian Precup, our speakers, Lucian Precup and Pietro Mele, who want to give us a deep dive into NLP with the Elasticsearch. Lucian is a good friend, I would say, in the search world, in Paris, based in Paris, works with clients in France, a CTO of all.site, and also with Adelean, implementing search solutions for many clients. And I also want to welcome Pietro as a software engineer working in the Elastic world, and the stage is all yours.
Okay, thank you, René. So yeah, thank you for coming, and thanks Open Source Connection for bringing us together again. We will talk about NLP and the Elasticsearch, and so I'm here with my colleague Pietro Mele. We had some issues with the other computer which has the demo, but hopefully by the end of the presentation we will have that ready. So we are Adelean. We are like search experts. We do professional services around search engines and Elasticsearch and OpenSearch and Solar. And we also build a vertical solution for e-commerce on top of Elasticsearch. And as René mentioned, we also build a collaborative search engine that's called all.site. So the roadmap for today, we will start like introducing NLP, but very quickly, because I think you all know many things around it, and the keynote today like introduced it really well. Then we will see why we need NLP for search. We will also talk about some use cases around that, so why it's this needed, and the implementation that we have available with the Elasticsearch. We will also mention some other integrations that do not necessarily need like a platinum license or something like that around Elasticsearch. And we will not talk about OpenSearch today, and neither Solar. They both have their own roadmaps on NLP, and they have similar things, even better things around this. But yeah, the subject of today's talk is like really we will look into the implementation that Elastic has done for that. But again, you will find many similarities with OpenSearch and also Solar. But like talking about their integration on that is like a new talk in itself. Okay. Just to give some credits for this talk. So this talk is largely inspired by a meetup that we held with our colleagues at Elastic in France. And yeah, so this is the original talk, which is in French. This talk is different. The original talk also talks about enterprise search. We focused mostly on the open source part.
So before continuing, I would like to know, just like a fast survey, how many of you use everyday life Elasticsearch? If you could please raise your hand. Voilà. And how many of you use OpenSearch? Just okay. That was just some funny, wanted to see how many of you use the different solutions. So let's dive together into NLP. So we all know that NLP comes from far away. It's an interdisciplinary field between psychology, computer science, artificial intelligence. And we have an overview of the timeline of NLP. So we started far away, 70 years ago, with the Georgetown experiment. It's nearby, where we had the first translation, first machine that could translate a phrase from Russian to English. First chatbot in the 20 years after. Then the small evolution, neural probabilistic language model. VirtuVec, so we all know what it is. It's a library that allows us to do vector embedding, created by Google. And today we have the yellow man there. So we have BERT, and the 2022 we have the star of of our life, we will say, of the web, ChatGPT. So how did we get this far? So we have way more data, so we can create a more efficient model. We have greater hardware than in the past. It's also less expensive. And third, least but not last, for importance, we have also new architecture. So we have the transformer. So we have the attention mechanism and transfer learning mechanism that are extremely important.
Yeah, so NLP and search. So NLP was always important for search, and actually it was there since quite of like the early stages. Trey mentioned this morning at the keynote, the inverted index is actually a vector with many dimensions. The dimensions are each of the terms of the alphabet of the dictionary. So yeah, the vector model was there, like in the scoring since the beginning. The search queries themselves are expressed in a natural way. So even if we don't actually ask a question to the search engine, if we just say something, just like 2 keywords there, there is some semantics in it. Yeah. So NLP is important for search since a long time. Now, when we started integrating NLP models into Solr and Elasticsearch and the search engines in general, there has been like a paradigm shift. You don't need like synonyms anymore. You can do multimodal search. You can use an image to search for text and vice versa. So it's a whole new way of doing things, and yeah, it has advantages of this and disadvantages as we will see. But it was a paradigm shift. Yesterday at the pre-conference meetup, we were wondering, so René was wondering what are the use cases for vector search and for semantic search and all that. But actually he gave the answer in the same talk, because there are use cases, especially in e-commerce. So the second part here is e-commerce. You have like everything that goes around personalization and for example, yeah, it can use vector search, can be improved with vector search. You can also act on customer reviews, for example, using NLP. In finance, you can monitor market trends. There's a lot of use cases in enterprise search, as Trey mentioned this morning, to like query technical manuals, and also in medicine, healthcare, and stuff like that.
So, sparse versus dense vector, that's it. We are between vector search or keyword search. What is better? We don't know. Which one is lighter, which one is heavier. We know that the pros for the sparse, so for the keyword search, we have faster retrieval. We also can do exact keyword matching, of course, but we may have some problem with the vocabulary mismatch problem. So sometimes we can't find a certain document because we are not just using the right words, or we don't have a search engine which is rich enough, so we don't have the right synonyms. We don't have semantic, of course, while with dense vector, so vector search, we use semantic. We can also have, of course, multimodality, so we can search for a photo using text or the contrary. But as cons, to have good performance, then we should fine-tune our model. And last, interpretability. We don't really know why we have certain results sometimes. So it's complicated to understand how our model works. Like some sort of black box for us.
Yeah, we always have a trade-off between scale, speed, and relevance. Now, to get into the details of what's available in Elasticsearch and in the Elastic Stack, because there's also Kibana involved there to some extent. So there are a certain amount of NLP tasks that you can do. You cannot do all the NLP tasks. There are limitations, so you can integrate some of them. And these are some examples. You can do like things around information retrieval, like entity recognition, like summarization. You can do question answering. You can also do a lot of things at index time, which are great for improving the relevance, adding structure to your text, adding structure to your unstructured data. So you can do language identification, you can do classification. Yeah, some exotic things like sentiment analysis that allow you to improve the relevance and to improve the analysis that you do on top of your data. And then, yeah, of course, you can do all the text similarity and text embedding.
So let's dive together into some of the NLP tasks that we can do with Elasticsearch. In this case, we have named entity recognition. We all know what it is. So we can, it's like a process. We can, the model can recognize different entities. So in this case, we have, for example, Charlottesville, which is a place, or we have an organization, an open source connection, and we also have a person, so Trey, like this is some credit also for this incredible event. So we decided to put as an example, and.
As a use case for this, and why is this needed for your search engine, is that it allows you to maybe add facets on top of the results that you have. You can use these entities as filters, and it adds structure, so your search engine will be more relevant.
Another NLP task, sentiment analysis. So we can use it to mostly in e-commerce. We can use it to understand like if a phrase is positive, is negative, or neutral. Like with in e-commerce, I mean the customer support. So it's quite useful as well. Next, we have the zero-shot classification. So in this case, we give an input to our model. So we may have in this case a phrase like I have a problem with my phone or with my iPhone. Then we can pass to the model some classes. So in this case, we passed the urgent phone iOS. These are classes that are unseen during the training, but the model can still say if the input, it can still classify the input as urgent in this case, as related to phones, and related to iOS because it's an iPhone. So
yeah, so how it improves your search engine, it's that you can add facets on top of your unstructured data, and yeah, you can improve the user experience mainly.
other extremely important case is summarization. So the capacity of our model can be used to summarize a text, and we can use this at index time. Like we don't want to index the entire document. We want to index and extract, but we can do this also at search time. We don't want to show the content of our result. We want to just show a part of it. So even in this case, in the field of search, we have many use case we can use we can use summarization for. And once again, last but not least, question answering. We saw many use case like since in search engines like Google, Bing. They do question answering since a while now. Technically, we pass two things to the model in question answering. We pass a context. So in this case, it's a graph of what is the Amazon forest. And then we pass also a question, and the model is gonna be able to infer the answer from given the context and the question, and the answer is gonna be into our text. Like we're gonna have like in this case we have like how many countries the Amazon forest cover. We have like the answer 9 that is found. Like we see the purple highlighted area. But we can go farther than this. This is called extractive question answering. We can go farther. We can have also generative question answering. So we saw it before during the keynote. Generative question answering, we are all abstractive. We can pass we pass a prompt. So in this case, we can pass a context and once again a question, and we ask the model to answer, and it can generate a coherent answer. Not always, but it can do it. Depends by the model we are using, of course. And the good thing is that it's more, we can say, it's more user friendly. Like it's nicer. It's a nicer answer than just have 9 as a number. You can have something more complete. So it's a better user experience, I will say. And to do this, we have a large range of large language model. In this case, it's like just an overview, timeline. We have both open source, they are lighted in yellow, and not open source solution. And we see a bit the actors. They are like investing, a lot of money on this technology.
Okay, so how does it work, like technically in Elasticsearch? So we have seen what we can do. Now we will see how we do it, and yeah, we will also like hopefully show you a demo of that. So the first important step is to integrate machine learning models with Elasticsearch. So for this we need two things. I mean, yeah, in the most straightforward manner, we need a tool that Elastic built, which is called Eland, and we also need models. So Hugging Face is a good source for that. So yeah, I think you all know what Hugging Face is. It's like a repository that is the GitHub of machine learning. So it's a repository for plenty of machine learning models that you can import. So the Eland tool allows you to easily do that. So to register a model with the machine learning node that's available on Elasticsearch site. So you can also specialize your nodes within the Elasticsearch cluster. You can have data nodes, master nodes, and you can also say that machine learning nodes are dedicated. Anyhow, these models have to be registered with the machine learning nodes, being like dedicated or like generic. In Hugging Face, so yeah, we will not necessarily show this otherwise than in this slide. You have this part here that's dedicated to NLP tasks. So as I said, not all of these tasks are available in Elasticsearch. So there are some that are not there yet. I think, for example, like conversational is not there. But yeah, you have access to all these Hugging Face tasks here. You have like a few thousands of models that are available to be integrated into Elasticsearch. This is something that we will show at the demo. You have a dashboard in Kibana that allows you to like do things, to register the models, to start the nodes, to do some debugging, test the model prior to using it to do in the Elasticsearch APIs. So yeah, we will get into this more in detail.
So how do we do in Elasticsearch? First thing first, we need to create a pipeline. So in this case, we have an inference processor. We know pipeline are used to enrich our document, and in this case, what do? It's we send our document. We see in this case it's a document with a single field message and a timestamp. We can send it through our model. In this case, it's like a sentiment analysis model, and using the pipeline, we rendex, and we can generate the result, the enriched document result that contains a prediction. In this case, it's going to be higher if the model the message. So in this case, we have this is the best feature message. It's going to be higher if the message is positive. It's considered positive. It's going to be lower if it's considered negative. So this is how it works technically. So pipeline and inference processor and reindexation. This is an overview, our workflow on semantic search. So first thing, we need, of course, to set up our Elastic cluster with the data and machine learning nodes, of course. We have to create the inference pipeline. This is for the indexation part. So we use inference Ingest Pipeline with our NLP model that is good for text embedding. And of course, we need to charge the model. We're using Eland as we saw before. We need to define the mapping using a dense vector field, because we want the content of our document to be embedded as a vector, and we can reindex. This is we say preparation, so indexation time. Search time instead, we kind of do the same thing. Like we use a query. We can search using a query. The query is passed to the model. So a vector is created, and then we can use the KNN to do, or the approximative KNN to find the closest matching document to the vector query. And we'll show you later how this has a bit evolved in Elasticsearch. Like last version, 8.7 brought some new features, some nice new features.
So as we said, there are some tools and some workflows that are available only in the like non-open source, or I mean, should I say? Well, it's still open source, but the platinum license of Elasticsearch. So if these features are not available in the basic with the basic license, you can always do the same thing by yourself. So everything that's available in the platinum license version of Elasticsearch is just integration. Okay, so everything is open source, and you just need to code a little bit in order to do the same thing. Okay, so don't get like yeah, don't be afraid to use these features by thinking, oh, I need a license for that and all that.
Yeah, we have some more workflow for the semantic search. We can say homemade, as Lucian said. We don't need to pay for it. Using Elasticsearch, of course. We know OpenSearch has other nice solutions as well. In this case, what did we do? We used a RESTful API. We used a Flask. We used the Hugging Face library, so transformer library, to upload our model, a BERT model for vectorization. We did the same thing that we did with we saw with the other in the other slide. So with with Elasticsearch, we did the same thing. So we indexed we created our vector. We indexed them into this vector field, and this is at indexation time, so preparation. And the search time, exactly the same thing. So we send our query to our Flask module, and the query is vectorized, and then we can use it in this case we have the old way to do things. So we have a script, but now it's just slightly different. Like we use the search endpoint differently. So as evolved.
So very quickly before the demo, this is an example of integration. We will show an example of integration that we did with all.site. And all.site is a collaborative search engine, so it's indexing the web, and yeah, it's using it's web search. If I refer to the 3 types of searches that Trey mentioned this morning, so it's web search. And why do we need NLP for that? Because you see, like when you search on Google, you have question answering. You need to classify the text, add structure to unstructured data, because on the web the data is mostly unstructured, and stuff like that. Yeah. This is an example for the question answering workflow, which is rather simple. So you just need, and these are techniques like you saw this morning also, like you use several tools and several APIs in order to build your end user result. So the idea is that we are using the search engine to get the best relevant results, and then we do like a post-processing in order to do the question answering. So it happens like this. You just like import the model. That's the first part there, the simplest part, and then in your search, when you have the search results that come from the search engine, you just have to go through a number of results. It's up to you to decide if it's the first page or the first results or the first 3 results. And then what we did, but you can do also differently, we use the fragments that the highlighter returns as a context for the question and answering API afterwards. And we also verify a threshold of confidence there. Okay, so as soon as we find an answer that has a threshold, in this example of more than 50%, we say, okay, this is the right answer, and we display it. And it allows you to display like this question, these answers which are on top of your results. So you have the results, and you display like a first result, which is the answer to your query. So sorry for the example is in French, but it's actually around what's the capital of Europe. Yes, so we will show a demo with Elasticsearch. And just during this demo, you will see, we have to figure out how we plug the computer. Maybe we can try to switch again, or if we have 30 seconds, we can put a Google Meet there, and like you do the demo on that one, and we display it here. Yeah. Sorry. So during the demo, you will see the evolution of the NLP integration. So in version 7 of Elasticsearch, you had like this brute force, like that Trey was mentioning this morning also, where you have to go through all the documents and verify them. Do they match, and all that. So you do that with a script. And yeah, it's rather slow, but it works. You can do vector search even in version 7.3 of Elasticsearch. And of course, it's not very scalable because you have a latency there. And then it evolved in version 8 when Elasticsearch introduced ANN. So they used hierarchical navigable small word graphs. So this HNSW. So this allows the scalability. And in Elasticsearch 8.7, they even like integrated that even more, and you will see like the evolution of that. So we have like modifications even till 8.7, which is quite new. Okay. So let's we will use another keyword keyboard for the demo. I'll just click here. You already clicked. Okay, yeah, you can see us on screen. I'll just stop the camera. Mute. I have also the companion mode, so that should do it. And how do I place this in full screen? Okay. Maybe if you increase the font size a little bit, well, I think it's. Are you? You're okay. 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 So, yeah, can you can come here if you want. So we will show a few use cases. The first one is language identification. So we will go gradually. So language identification is kind of simple. So we will like start with this simple one just for you to get the idea, and then we will end up with the most complex ones.
So yeah, sorry for this parkour. So yes. Of course, Q&A is dead. So just to show you a bit what we said before, so this is the interface of the model management in Kibana. So we have different information about the model that we previously charged. So in this case, we decided to charge some model for text embedding, some for question answering, and some for named entity recognition. And this is our like the tag we use to upload our models. Just to give you an example of our index, like it does contain a few documents of different kind we ingested from Wikipedia. I think. To give you an example of how the interface works and what we can do, how we can use it, we can test our model, and it's going to be tough to write something with the microphone at the same time. And in this case, we're using the model. For example, this is a model that is just already uploaded by default in Elasticsearch. We can use to inference information about to recognize the language. So in this case, I wrote in Italian, and it recognized that yes, this exactly looks like Italian, and we can see also different results like Macedonian. So maybe Macedonian looks like Italian. I don't know, a bit. Okay, so funny. So we have our index. We have some documents. How do? We just use inference and ingest. We create our pipeline. Like in this case, we are just specifying the model that I showed you. Oh, this like ident model 1, fancy name. We use a target field. So we say, you know, when read my text and tell me what is the result, well, you ingest this in the target field, so the text language. And then we say what is the source for what we should send to the model. What in this case is the text field that we are sending. So we can create our pipeline. We have to reindex always, and finally we have the results. So it's exactly the same thing. So in this case, we have a predicted value. This is English, and probability that this was the right value. But we have also our other document that should be in French. So like in this case, and we have good prediction. Of course, this doesn't work always. Depend also by the model. It's a small model. As I said, it's uploaded by default on Elasticsearch. And also depends by the text we send to the model. I mean, if it's too short, maybe not too good. Maybe not give good prediction results. Yeah. And, second part, named entity recognition. We can do exactly the same thing. So in this case, we are using another model. We are using BERT, Slim BERT. We decide a new target field. We use the same field map because we want to do it on the same field. It takes more time because in this case we are looking for the different. I'm gonna show you. We are using we are looking for the different entities in our text. So with the named entity recognition. I think it's gonna be tough to show it to you like this. Well, thank you. I'm gonna do something like this just to show you a bit the interface of Kibana. So in this case, we have the different entities. Like we have both the entity itself, the type of entity, person, miscellaneous, all places, location, and we have also the probability that this is a person. And yeah, it's a person. So we were there. We did our index. It took some time, and yes, we have our predicted value. Like in this case, we have it in our field, the one we say that's target field, and we have our entities, the same as into the dashboard, in the trained model dashboard. And we have the same thing, class probability, class name. So we can use this, as Lucian said before, for faceting. It's quite useful. I'm gonna go fast on this. Question answering, same thing, same model. We can use the inferior endpoint to get a document, to get an answer given a context in that document. A context and a question. So we got our answer, we have our prediction probability. And this is, I think, the most important part. So the one about vector search, because such changed rapidly in the last months. With Zoom. Thank you. Okay. So as we said before, we need to create an index using a dense vector. Then we have to pick the dimension we want, and we need to define index as true. This is extremely important. Otherwise, it's not gonna work. We use the same ingest pipeline, and then we can infer as we did in the other use cases. Important part in this is how the endpoint has changed, how we do vector search using Elasticsearch. So this is the first way, the old way. So we use a script. This script contains our vector, like we have it here, 384 dimension vector, and it calculates causing similarity between the vector and the vectorized document in our index. Just to give you an example, because I jumped this, we already have vectors did by inference, and this is the endpoint to create our query, like Italian poet. So we use this here, and we have our result, which is Italian poet. It's of course Dante Alighieri. Well, the new endpoint uses is the search endpoint. Elasticsearch wanted to use another endpoint that was the semantic search. Then they decided to do everything in the search endpoint, and gonna show you why. And it's kind of the same thing. So we still have the query vector, and we run the query, and we have the same result. So this is in NN, so approximative nearest neighbor, and we are using k 100 number candidates as a parameter. And this is from the version 8.7. So this is the last version. This is the last how we do it now, with the last version. So we have the new parameter query vector builder, and this allows us to create to embed in we can say in real time directly in the query our vector, and it works like charm, the same thing. And of course we can combine semantic and keyword search. And this is why they decided to abandon the project of semantic search endpoint and decided to go on this. So that's all for the short demo. We try to do this as fast as possible. Okay, so now we can.
So this combination between full text search and vector search it's very powerful. Actually, so okay, we'll move back to the. Okay, slideshow. Yes, so we have everything ready here. I think I'll let you.
So yes, thank you. So the joke is what do you prefer? Do you prefer an extremely long query like this one, or do you prefer an UG? And well, you don't have to choose between the red and the blue pill in this case. You probably can take both, and Elasticsearch looks like it's going for that way, using the search endpoint for doing the same thing. So we can combine semantic and keyword search, and some short conclusion. So we have a new range of tools, as we saw, that allow us to enlarge the search horizon. We can do multimodal, multilingual using the semantic search, but BM25 is still in the game, of course, and we have we can still use it. I mean, it's still working, of course. It's always important to evaluate the impact on relevance, and of course we must mostly if we are using semantic search, track and measure relevance. So some references.
Yeah, so we have finished, and yeah, these are some references that allowed us to put this in place. Thank you.
Yeah, thank you to our speakers. I would say one quick question. There was one on the Zoom, but it's been answered, I think. Thank you for asking anyway. Any questions here in the room? No. Okay. Oh, there's one. Okay.
Do you have any recommendations on how to tune the weights for semantic search and keyword search? From what I understand, it's a linear combination, I think, when like calculating the score. So for the weights for each of those, do you have any recommendations or hints on how to fine tune, I guess, the weights or come to the most optimal combination?
So please wait with the answer.
Yes, I think we can. For example, we saw with the new endpoint, we can also boost, for example, our results. So we can decide to put a boost on certain fields. We can decide to put a boost on also our KNN results. So we can use that, for example, to modify, let's say, the importance of the semantic over the keyword phase.
Okay, thank you very much, and thanks again, our speakers.